In this set of lessons, we're going to look at the circle in more detail. What we know about the circle so far is the formula a equals pi r squared and c equals pi d, and we know a bit about sectors and arcs, but we don't know about equations of circles and how to find centre points on them. Also, points of intersection between circles and lines and things like this. So, first thing we're going to look at here is the equation of a circle. This is given in the exam and it'll be on the formula sheet, so you don't have to memorise it. What we do need to do is be able to use it to work out details that are asked of us. The first thing I'm going to do here is I'm going to prove it from a simple diagram and a bit of Pythagoras. You won't need to do this, but it's interesting to see where it's come from. So if we look at this diagram here, a circle with a centre point C and a point on the circumference P. If we use a bit of algebra and call the point C AB and call the point P XY and the radius R, to try and come up with this formula, then if we create a wee triangle here, we can use this to work out what r squared is equal to. If you think r squared here is equal to all this. So if you look at this right angle triangle, really what we're doing is we're trying to use Pythagoras to work out r squared. So we need to square this side and add it to this side squared. And that's really what we've got here. We've got this squared plus this squared equals r squared. That's just Pythagoras' theorem. So where does the x minus a come from? Well, to get this length here, you subtract the x coordinates from each other. For example, if this was 9 here, and this point was 7, then the difference would be 2, so you would take these away, so that's x minus a. Using the same idea, to get the up and down part, you do y take away b. Then you square them and add them together to get r squared. So CP, this line here squared, is equal to this, therefore that's equal to r squared, and that's where it comes from. A wee point to note, if AB is equal to 0 and 0, then this equation falls down to x squared plus y squared. And we're saying here the equation of the circle has a centre point AB, and this is the radius. So if the centre is 0, 0, i.e. the origin, the equation is just going to be this, x squared plus y squared equals r squared. So let's look at some examples you might be asked of. So it says write the equation of the circle with centre 2, negative 5 and radius 4 root 3. So this is, in sense, substitution. It's a substitution question. This is your a value and this is your b value here. So we're going to have x take 2 squared plus y take away negative 5. So that's plus 5 squared. And then the 4 root 3 squared. Square this out if you're asked in the question, and simplify it. So 4 root 3 squared, this means you square the 4 and the root 3. Some people forget to do that. So the 4 squared is 16, and root 3 times root 3 is just 3, so that's 3 times 16, and that comes to 48. That would be your equation of the circle. In the next example, we're going to look at how to find the equation of a circle, but this time we're not given the radius. We've been given the centre point, and we're told that a point in the circumference, but we've not been given the radius. This is where you use the distance formula to calculate the distance between this point and this point, which will give you the radius. The distance formula is just Pythagoras again. You find the difference in the x values, square them, the difference in the y's, square them, add the two answers and then square it at the end. All you do is you do it in one line. So if we look at this, this here is the difference between the x coordinates. This here is the difference between the y coordinates. You take them away to get the difference. You add in Pythagoras here because it's the hypotenuse you're working out, and you square root it. The way I always do this first, I work out the brackets. So -7 take away -2, that's -7 plus 2, so that'd be -5 squared. I think I've got a 5 here, but it should be -5, I'll just change it. And this bit's going to be -2 take away -5, which is +3 squared. So we'll just change that to -5. It's not going to make any difference in the actual calculation. But it's better to be accurate. So -5 squared is 25. 3 squared is 9. So that's going to be square root of 34. Now I'm not going to actually get that as a decimal calculation. You'll see why in a second. So we're talking about the formula of a circle. So the equation of a circle uses that from your formula sheet. Your centre point is A and B, so it's x take away -7, so that's going to end up as a +7, and y take away -2, so it's a +2. And then when we square root 34, you just get 34. So that's why I didn't get a decimal answer to this, I just left it as a root. Last example here, show that the point 7,5 lies in the circle with the equation x minus 3 plus y plus 2 squared equals 65. So what we've been given here is an x coordinate and a y coordinate. If you substitute these in here and it comes to 65, then it lies on the circle. So when x is 7, y is 5, put it into the equation, 7 there and 5 there. 7 take away 3 is 4 squared, plus 7 squared, that's going to be 49 plus 16, which is 65. A wee statement says B lies in the circle since the point satisfies the equation. Just a wee point to note, if you substitute the value in and it's larger than the radius squared, then it lies outside the circle. Equal to the radius squared, then it's on the circle, and less than the radius squared, it's inside the circle.